Hey everybody, this is Larry. This is me going Q4 of the bi-weekly contest 142. Find the original type string 2. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. Yeah, this one is a hard problem, and as you can see, only 164 people got it, so it was very tricky during the actual contest. I did this in about 40 minutes with penalties. Silly penalties, but still kind of, it is what it is. I actually, one thing that I would point out is that if you really want to kind of, I'm going to go over it anyway in a step-by-step kind of way, but if you really am curious how I attack this problem in the 40 minutes or whatever it was that I took, or 35 minutes that I took, watch the live portion. I actually, so for this one, I initially came up with a solution that was time limit exceeded. I actually honestly just did the math wrong, so I thought it would be fast enough, but I just did the math wrong in my head. I forgot a factor, so it was 700 times too slow or something like this, or whatever it is. Whatever it is, it was too slow. But writing out the TLE, the time limited version, allowed me to see what I needed to do to solve it. So maybe there's a chicken and egg thing in that, like I needed to solve the problem this way to be able to, like I needed the time limited maybe to solve the problem. So maybe it is what it is. But also maybe that, like I maybe would have been able to figure it out later, but it would have maybe also cost me more than 5 minutes from the time limit exceeded. So I don't know. But anyway, so for me, for this problem, well, one is that it's just dynamic programming, but for me, for this problem, I just had trouble visualizing the solution. So I needed to write out the code, and sometimes, like this also points to the importance of practice, I want to say, because I think people did it kind of quickly. They're really good people. For me, I kind of had an idea, but for this kind of problem, I don't have good visualization until I type it out. I guess I'm just not practiced on it, but that's why I talk about practice a lot. Right? So when you practice enough of these things, you're able to kind of skip some steps. But for me, like also to be clear, like I'm not trying to too hard to get better at stuff like this, so that's why I don't practice. But if it's your goal, then you should definitely focus on this part, right? Okay, so that's kind of a little bit on the meta side, on kind of talking about this problem. But for this problem, and I actually think I did okay on the live portion, like talking aloud, because I wasn't able to get this. The first thing to notice is that you have this thing of k, right? At least k. So it means k plus 1, k plus 2, k plus 3, all the way to infinity. Or technically, k to n, right? Because k can only go up to n. So the first thing I noticed is that, well, the constraints are k is less than or equal to 2000, which I thought was a little bit weird. Because then, but it also allowed me to think, okay, can I think the opposite? I think that's the key point, right? Because for this one, you get the two ways to think about this one, right? One is solving it, for at least k, you could solve it for k plus 1, k plus 2, all the way ... to n, or you take the reverse of it, which is solve it for k is equal to 1, k is equal to 2, or exactly k, not at least, but k is equal to exact 1, k is exactly 2, k is exactly 3, ... all the way to k minus 1, and then you just subtract it from the whole, right? Yeah. And here for this one, I think we, for the all possibility, we just have to figure out, this degree of freedom thing, right? The degree of freedom thing is just how many choices we can make at every given thing. And here for this, this is a little bit too even. Okay, I'm just gonna add some random A's and just a D. But yeah, but you can kind of split it up by similar characters like we did for Q1, right? But now, because they're independent and you get to choose, well, how many choices do you have? Well, in this one, you have 3 choices, right? In this one, you have 2 choices because you can have B and BB, so you have 2 choices. So that's really the way that I would think about it. And now, and like in Q1, all of them kind of adds up, right? So then now, how many possible strings are there in general, in total, right? It's going with no regards to the minimum length, right? It's going to be just 3 times 2 times 2 times 4, right? This is kind of basic combinatorics stuff, basic counting principles. So I'm not going to go over it too deeply. You might need to review your math a little bit if you struggle on this part, honestly. Also, I would say as a spoiler thing, this is way too hard for an interview. So if you're studying for an interview, maybe it's okay to not care about this particular problem. At least, like, you have other things to work on, right? Probably. So do that. But in any case, yeah, so this is just going to be 3 times 2 times 4, and that is the idea, right? So then now, so this is total number, but yeah, but now we're just trying to figure out, okay, well, yeah, so we're just trying to figure out, okay, what if k is equal to 1 and k is equal to 2, and then we just subtract it from this total number all the way up to the actual k that they gave you, which I guess is a little confusing the way I say it. But let's just say for I, for I is the number of it's the exact number of characters, right? So of course 1 is not possible because you have at least 1 characters of each, right? Because you press that button, so this is equal to 0, this is equal to 0, so dot dot dot, I has to be at least 4, you have at least 1, right? And then so forth. That's the way to do it. I don't know what 5 is actually. I guess technically 5 should be 4, right? But yeah, and then you just kind of sum it up and then subtract all these numbers from the total number, and that'll give you the answer for k or greater, right? All the way to I is equal to k minus 1 is what you want. It's equal to some answer, right? Okay. So we have stuff like this, right? And then, okay, so the way that I would think about it is just by writing the brute force, or not brute force, but the more naive version of the dynamic programming. So here, first of all, I do the group by thing to kind of group the words together, the characters together. Sorry, because this will give me the number of unique characters in the sequence, right? And yeah, and we just kind of put them together in an S kind of way. So if you kind of look at this example, then the S would just be just 3, 2, 2, 4, and P would be what, this number, which is what, 6 times 4 is 24, so that's 48, right? So something like that. So and of course we mod it, but we don't care about it. Okay, and then the next thing is, okay, if k is too small, then we have every possibility, right? Because basically, and this is the number of different chunks of characters, and basically if basically we have all possibility, we can just return P because we don't have to subtract anything. There's just an early termination. You probably don't even need this, but that's just a way, But if you do the rest of the math, it will just return P minus 0. So you might as well return a little bit early. And this is the dynamic programming. This is the naive dynamic programming solution, right? So basically, how would I define this? Index is the index of S. Remember, the S is the one with the numbers that we care about, right? And it can go to n. What is n in this case? N is for me length of S, which can go up to technically as high as the 5 times 10 to the 5th, but it gets pretty high. Left is just the number of k's left. Number of characters we have left, right? To fill out. Keeping in mind that the function we want to solve is not the at least k, it is at most k, or at most k minus 1, really. And so now k minus 1 is the limit of what we can do, right? Yeah, I mean, this is actually probably a little bit imprecise the way that I actually have this structured, even though it was incorrect anyway. So it's or like it times out anyway. But what I should have done in a more precise way is that this should be k minus 1, and then this should be should have made the bounds this way. So then it's a little bit more precise, honestly. Because I think that's more precise of the language. But in any case, yeah. So then now it's just basically, okay, well, we have left is the number of characters we have left, and then the index is the thing that we care about. It can go up pretty big, right? Left. So this is actually bound by k. But yeah, and then now we have I thought I stopped it. No. Oops. I guess I did. I think I missed the thing, but okay. Yeah. Yeah, so the idea here is to just, it is more of a naive dynamic programming. And yeah, it is that, okay, well, we know how many characters of S sub index are there, and we can go from one or all of them. So then we just recursively go, okay, well, now we go to the next index and we subtract them from the number of characters left. Again, we cannot go to the negatives because then we just ran out. But if we are exactly k minus 1 or whatever, then we go. The problem, of course, is that, okay, so the number of inputs can be pretty big. Index can go pretty high. Though it's not quite 5 times 10 to, I mean, 5 times, it can definitely go 5 times 10 to the 5th, but it's not quite that, because then, well, I mean, if that's the case, then k cannot go down by that much, because, or there's no variation of the possibility. So this one is fairly hard to analyze, even just the number of inputs, which is how I analyzed it incorrectly the first time. And what I mean by that is because basically if you have 5 times 10 to the 5th, it can only happen with its all ones, right? So then now, that means that after 2000, it's going to be just gone anyway, because k can only up to 2000, so it's not possible. So k does get bound by this thing, so that means that actually n can only be k, I think, right? Maybe? Am I wrong on this one? Give me a second. So n is great. Yeah. Maybe this is actually a cleaner way of saying it, actually. And the way that I maybe could have rewritten this is that I put n up here, and then now, yeah, right? So then now we can see here that if n is greater than or equal to k, then we terminate. So this is actually n is greater than or equal to k, right? So okay. But that said, the number of inputs is still n or k squared, sorry, right? And each input takes this amount of time, which can at worst be, I don't know what, I think you can do some math, right, around n and k, right? I think the square root of 5 times 10 to the 5th is the worst case, because then now, this is 700, but then now this also is, so this, in the worst case, I think this could be square root of n, and then, but then the number of inputs would be, in this worst case, it's going to be square root of n times k, but then now you multiply them, because each input, number of inputs times each input is going to be O of n times k, which is too slow, right? But that's fine, right? But how do I think about this one? So the way that I think about this one is by visualization, right? Like I said, and until I write this code out, I don't have the visualization. But for most people, probably honestly, this visualization is not good enough. And this is how I would think about it, right? Is me putting up a thing to join, is that, okay. The way I think about these problems after writing it like this is that, oh, my pen is upside down. I was like, why am I not drawing? So you have a grid, right? And we'll look over the code simultaneously in a sec. I think that makes it a little bit clearer. Is that okay? So we have a grid, and this grid is a dynamic programming grid. Sorry, just to be clear. So then now maybe you have you write. I can write upwards. Okay, fine. So here maybe we have index, and the other one we have what I call left in the DP, right? And let's say that this goes up and this goes to the right. Though now I have a thing that's left pointing to the right. It's confusing, but okay, fine, right? But okay, so then here we try to visualize what this thing is trying to do, right? So for a certain cell, let me change the color real quick. Okay, that didn't change the color. Okay, so for a certain cell, I'm trying to visualize what it is trying to look at, right? And for here, in the code, we do a sum of index plus 1, which is the column on top, and then left minus x, where x is a range, right? So it's a continuous range, which is important for this one, right? It's not just it's not a range with holes or anything like that. And what I mean by that is that if you have if statements and different functions or whatever, it is literally just, if you look at this, then index plus 1 and left minus some x. So it's going to be some some chunk that is something like that. So basically you're summing over some amount of another matrix. And from this, from writing it out, then now I realize what I have to do, because now that means that you can convert this into first bottoms up, right? And after you convert it to bottoms up, then now we can pre-process these rows one at a time. And that's basically what I did. Let me go back to the code. But I hope the grid makes it a little bit easier on the visualization, and that's how I attack these problems. And if you watch the live portion of it, I actually do this very deliberately, which is why I have the code. It's not because I wrote them separately for the video, for the recap video, but it's because I kind of wrote it that way. So this is the first step I did, is convert it to a n times. This is exactly the same problem. This is exactly the same solution, except for that it is bottoms up, right? So this is my slightly too big, but that's what she said. This is the top down, right? So I basically convert this to this, right? And to put it side by side, I'll put a comment here, and that's really how I did it anyway. I just look at this, and then I think one additional thing that I would say is that you can also notice that there's a space optimization. I did during the virtual contest, I did miss this thing where n has to be less than k. So I thought n could be maybe big, but I just kind of forget. I don't know. There are a lot of things to mix together, so I didn't really focus on it. So there is a space optimized version of this as well, because index just depends on index plus 1. And in fact, the version that I submit, I do optimize for it, but because I did the math wrong and I did an extra optimization, but that's also okay. But but basically all I did for the bottoms up here is just converting this function to this thing. You can the way that I do it is just literally, I do the for loop. I make sure the for loop is in the right order, which is that index depends on index plus 1. So I convert it to go backwards, so that index could look at index plus 1, and then left I just go forward, because it shouldn't matter because it's always on the last row anyway. So it shouldn't affect things. So this one, the order matters less, and of course the X order also doesn't matter that much, because it goes both ways and it's fine, right? But in any case, so this is, and you can see that if you look at this for loop and this for loop, everything is pretty precise. It's almost copy and paste in a different way. The only thing that's a little bit weird is, of course, the base case, which I kind of look at. If you look at through this, you go, okay, well, if index is n and left is greater than, you go to 0, then set it to 1. Actually, you know, as we talked about, this should be maybe k minus 1 from, and this would just go from 0, but it's too late for that. So yeah, I just kind of it's an off by 1 that I did, and I converted the original way, so that's why it looks this way. But if I had it the other way, I would have converted the same way, right? But yeah, and this is, like I said, they're the same, and I checked and verified they're the same. Of course, if this is negative, it's going to be 0, so that's why I have this if statement to kind of, you know, because 0 doesn't change the answer anyway, right? So that's why I did an if statement instead. But you can imagine either shifting or doing something funky to kind of accommodate it if the if statement was something more complicated. But yeah, but this doesn't solve our problem, right? Quite yet, because, well, I mean, now we can count the loops and it's easier. We have n times k times another possibly, you know, the biggest number in S of n. So like I said, you can maybe like make a square root thingy, so it would be like 707 or whatever. So it becomes n times k, right? Which is too slow. But okay, but the two things here, right? One is that we noticed the space optimization, which we will do. I wish I saved the space optimization version, but it turns out I guess I didn't. But yeah. And then the second thing is, as we said, let me bring up the visuals really quick, is that now that we did bottoms up, you want a column of this. So what do we do with this, right? Well, we know that, okay, well, the red one, we want this chunk, and maybe the blue one, actually, I guess in this particular problem, the way that I'm doing it, because x is always the same for an index, and if you go this way, then the blue one would actually be this one, right? So there are a couple of ways you can write this even now that I see it this way, right? And let's say green will be these. I think I overextended, but you get the idea, right? Because x is always going to be the same. So you could even do like a sliding window thing, which is fine, because x is constant per index, right? And because we're doing it one row at a time, we can definitely do that. So that's actually one more thing that you could have done, but I actually didn't. I don't know. It wasn't necessary to me think about, because the way that I did it was with prefix sum. Let me actually again fix this really quickly. But yeah, the first thing I did was the space optimization, noticing that index only depends on index plus 1. So I have a previous index and a new index, and I set the base case up, right? And okay, I mean, obviously I don't have it anymore, but if you, yeah, you get, it just looks like this really. But yeah, and then the next thing, of course, is by doing it with prefix sum. We call it that, you know, we have this thing, right? When we have this thing, then we just, what I can do, I think if I did sliding window, it would have been much faster, and I messed up on some of the math, so I made it a bit slow. But you can think of, let's say the red chunk. I'm going to write it down here so that it looks a little bit, you know. So the red chunk is just equal to this chunk minus, now it looks like poop. Okay, let's choose another color. The red chunk is just equal to this bigger chunk going all the way minus the smallest chunk, right? From here, projecting this way, right? This problem is hard enough, so I'm not going to go over the prefix sum in detail, but that's really the idea, and that's how I kind of construct the prefix sum, right? So the only difference is that I construct prefix sum on the previous index row, right? And then now for each one, we just have to do the math on the index. And I guess I took it out, which maybe is a little bit unfortunate. But the way that I looked at it was that, okay, so I have this function, right? So let's actually put it here real quick. And it honestly, this took me a while, so I'm sharing as maybe a tip in case it takes out of pure confusing as well, is that calculating these index, I go, okay, well, you have this thing, right? So I have to reduce this a little bit, right? Well, we know that left minus x has to be greater than 0, and x goes from 1 to s index plus 1. So then now, what is the minimum of this range, right? So we have to do this thing. What's the minimum of left minus x? Well, x is 1, so the minimum is going to be left minus s index plus 1. Unless this number is greater than left, then it's going to be just left, right? So it's either min of this or left, which means that this is equal to 0, right? So it's either, so another way to think about it is either it is this number or 0, right? Because if this number is negative, then it's 0. So that's the min number, because this range min is the smallest when x is the greatest, right? And then the max number is just going to be, well, x is at least 1, so the max number is going to be left minus 1, right? So this is the min, and this is the max of your range. And of course, prefix sum, I have an extra 0, so I have to add 1 to these. The 0 is still true, I suppose, but yeah. Actually, and also this is I without parents, which is why I actually screwed this up during the contest as well. So, but yeah, so you have this, right? And then yeah. So you need a plus 1 on this side, because so this is inclusive, right? So that means yeah, that means you want to subtract from the min minus 1 on the prefix sum. So this is this minus 1. So then now the plus 1 cancels out, and this is how you get this, or of course 0. And then on the left side is left minus 1, but then you want to include max, so you have to add 1 to it because we have an offset of 1 element here. And that's really how I got this bound, and this bound. Ooh, and that's pretty much it. It's just prefix sum. So yeah, I think the biggest thing, I mean, I think this code is pretty okay. I don't know that you can learn that much from it, but I think the key thing is this visualization of okay. And of course you could have done this in sliding windows, which is fine, but you just have to do it, right? That's all I have with this one, I think. Let me actually go back to the code so you can actually stay on that. But that is all I have for this one. Yeah, and you have to, of course, remember the mods. But yeah, it saves a lot more space when we do the space optimization for, I mean, it is in the name. But I don't even know if you need to, so I don't know. But that's all I have for this one. Yeah, oh, let me go over the constraints, or let me go over the complexity really quick now, right? Well, now, what's the time complexity, right? It's going to be O of n times k, but keeping in mind that this n is at most k, so it's going to be k squared. And k is only at most 2000, so we're very good, we're very happy, and that's it. In terms of space, this is O of k, this is O of k. I guess this is O of n technically, but so n plus k. And I think yeah, you just have to subtract it from the p. I think I missed mentioning this earlier, but p is all the possibilities. So then now you just subtract from the p, and you're good and you're happy. And that's all I have for this one. Let me know what you think. Thanks for watching, and yeah, I would also say that like the live portion, you can see me actually break this out, including the space optimization. So I actually have a version of this code in the live recording where I did the space optimization, but without the prefix sum optimization. So you can check that out. You can watch it on 2x if you like. I think it's actually, I did it way step by step during the live portion, so I think it's actually maybe educational if you're interested in that, so definitely check that out. But that's all I have with this one. Let me know what you think, way step by step. Thanks for watching, and you could watch me solve it live next. Maybe it times out and then Leetcode makes me sad anyway. Okay, it's good. All right, let's go. Q3. How am I doing on time? I have hour and 12 minutes left. Oh, I guess the leaderboard is not real anymore. I feel like the old virtual contest, they tell you like the ongoing rank and not the final rank. So that's actually, the leaderboard now is useless, which is actually kind of sad. I don't know how they mess things up even more, but Leetcode finds ways to do it. Okay, stop ranting. Okay, there's a modulo, so let's focus on that first. Mod. Don't forget the mod, Larry. Okay. Okay, let's see. Oh, this is different than Q1. I thought so because I couldn't figure out how you would just read. Okay, but given a word with given a positive integer k, the total number of possible original strings such that might have a length is big, k is 2000. All right. I guess we'll see what happens. What does it mean? What is k again? Okay, so if there's no k, what is the answer? If there's no k, this is 2. Is it 2? There's one string for the original string, which is 0 A's and 0 B's, and what is k? Oh, k is length 3. Okay, what if there's no k? If there's no k, it's a dynamic program. If there's no k, then it is just 3 times 3. Is that true? Because you have 3 degrees of freedom on A. No, you have. No, that's 3 degrees of freedom on A. How is this 3 then? Or how is this 8? Isn't that 9? Is the math? Is my math wrong? If there's no k, then what is the answer? I need a pencil for this. This is a pencil problem. Get my pen. Okay. Okay, so now we have. Oh, I guess it has to exist once. So you have A B, A B, A B. No, that's 9. Okay, so the only thing that cannot exist is AB, so which just makes it 8. Okay. Can I do a prefix sum on this? I feel like I should be able to do a prefix sum on this, but it's not exactly k though. It's at least k, so it's not always necessary. Is that too many dimensions? Probably. 5 times 10 to the 5th. No, it could be like 2 to the whatever power, so that cannot be crazy. But k is... Why is k so small? Dun, dun, dun. K is small so that you do the opposite. This is a trick. They're trying to trick you. So that means that you actually want exact or k minus 1 or less. Can I do k minus 1 or less easily? That's 2000. So my intuition should be right for the naive case. But, and then you subtract out, let's say you only have two things. Well, maybe you have a lot of, I guess it doesn't, it only matters about consecutive. For 5 times, for, what's that, half a mil? Well, half a mil, you can do a lot of, well then K would have to be really big. Is the math right? Can the math be right? Is it too expensive? No, that doesn't make sense. That would be too easy to mess up the math. Okay. Can I write this mathematically? So let's say we have, okay, so 3 degrees, so you have 3 degrees of freedom. When you take, so in theory that would be a regular DP, but there's just too much, too many things, too many indexes. Even if you just have like 10 choices each. No, because then you'd have like 500 times 1,000 or something. And then it would be 1,000 times 2,000. Is that way? What is the... Maybe the worst case is in the worst cases I think it is. Well, if you have one thing, if you have two things, no, then it's the square root, right? So what is this? So 707 is the worst case. So 707 times. That can't be right? That seems too silly, but okay. Let's try it just because that feels right on the math. So it becomes a math problem and not a programming one, but I think that's maybe right. Maybe not, I don't know. But I don't have any ideas, so I feel like maybe getting a penalty is fine too. Okay, so then now we have whatever. Okay, and then now we want to say k length of s, right? Okay, so if k is too small, then all of them count, right? So if k is greater than length of s, then we just, or even you go to, or is it the other way around? No, the other way around. Because if k is too small, then all of them are possible. Yeah, because you can't go any lower. So then it is just the summation of all the products, right? Okay. Well, I think we have to do this anyway, so okay, p is equal to 1. Okay, so then now in this case we just return p. Otherwise, then now we have to do a dp, right, of index left, right? So index is equal to n, where n is equal to length of s, and well then if left is equal to 0, wait, no. Okay, focus now. You want k or less, or less than k. So that means that auto inverting is hurting my head. So you want less than whatever. So that means if it's greater than 0, I would say this is return 1. Is it return 1? Okay, let's use real things. That's how I need to do it. So let's say k is 3. We get to the end, so k is 1. That means it's too short to that. Okay. Otherwise, we return 0, and then also left is. Okay, and then now we just do 4. There's probably, I don't know if this is right, we'll see. Something like this. Well, maybe not. oh no, but this is p minus this. Okay. Is this right? I don't know. Let's try something funky for a second. I mean, it has the right answer, but times but let's do at least a little bit of testing. That looks okay. I don't know if it's actually right. Oh, because it just has different k. But that's not the worst case, possibly. Worst case is maybe a. That's still not the worst case, but I think that's an interesting case. Okay, that's fast enough. And then the other case would be whatever, we can actually just skip this part and make it so that s is equal to 700 times 700. That's actually fast enough. Okay, well, let's YOLO submit. 518, okay. If it times out, I'll be a little bit sad, but I also don't know if it's just a Leetcode thing, if it times out. I mean, maybe they'll hide the case, so I wouldn't even know it anyway. But, oh, wrong answers. Oh, okay, fine. I thought I needed to add a mod here, but then I just forgot. I was like, oh, wait, I forgot. I changed it last second, so yeah. Okay, that was a little bit silly. But the annoying thing is that we might still time out. So that's a very silly 5-minute penalty. Yeah, okay. I thought, what is this? I guess I didn't choose the K to be enough on my examples. I think that, okay, I messed up on my testing because I didn't choose the K to be enough. I mean, 8 seconds is not fast, but it's definitely, yeah, okay. I messed up on my testing because I thought that I tested the harder enough case. But, okay, so what I should have done is, I forgot about that case, but K is equal to 2000, say, right? Then now 2000 is part of this. So we have to do a little bit better. Yeah, this time limit is exceeded. Okay. I mean, if I had tested that, then I would have. But of course, this would have been whatever. How much time do I have left? 10-minute penalty is a little sad though. Already. And I should have. I mean, this one. Okay, focus, Larry. It's okay. You can cry about it later. What is this? Let's see. Just want to see what the composition of this is. There was no chance it would have passed, so okay. I thought... Oh, I'm dumb. This is 700, but then this is a for loop of 700. Can I compress this for loop? Yeah, I mean, I did the math wrong, actually. It was more of a prayer. But, I mean, it is right, just not fast enough. How would I make it fast enough? So this left minus x. So this is a sum over a range. Okay, I don't know why this is actually I got this. I got this. Come on, Larry, you got this. 53 minutes. This is. You should have. Come on, Larry. You just didn't. I don't know. I think I did the math wrong. I didn't focus enough. But okay, so that's gonna be n times k. What is that anyway? N is only 41 on this one, but I mean, it's just a range sum. Index of left. I mean, you've done this one before, but I don't know why I'm kind of... Yeah, you've done this problem before. Come on, you got this, Larry. You got this. But even if you are not thinking correctly, but you just can't do it the naive way, that's why. Okay, so... Slow down, Larry, it's fine. Let's rewrite this for a second. We know that this answer is this thing. Okay, let's open a new window so I could at least keep this code actually as a verification for me converting this to top down. Okay. Okay. Don't prematurely optimize. You have to optimize, but not now. Focus on doing it afterwards. Did I not change this to big K? Let's change this to big K. Okay, write the dumb solution first, and then we can focus on later. Okay, fine. Right. Let's do it the other way. I'm too lazy to think about this. N is okay. With Gucci and whoops. Oh yeah, I actually did remember what's gonna write. And then it's just zeros anyway. This shouldn't be right because everything's zero. I didn't set the base case, but I just want to see that it is hopefully slightly faster. Actually, what the? How did I? How did this give me an answer? Everything should be zero. Oh, because it's p minus this. Okay, fine. That's fine. Okay, what's my base case? I forgot my base case. This is my so index is equal to n. So we just want dp of n of order left equals to z. Okay, that's actually pretty straightforward. Hey, that's very well. Hey. Left is greater than 0? Okay, so that means... Oh, yeah, because we want something strictly. Okay, that's fine. Technically, but I guess we can just remove an index, but I think this is fine. Okay, so now we translate it to bottoms up. First thing to do is space optimization. Okay, yeah, let's do it. I mean, really, you can do it both ways, but actually, let me again reopen a new window so that I don't have to worry about messing up. I mean, or whatever, so I can have a copy of it. Okay. Okay, so this is good. Everything should look the same, except for that dp sub left. We look at it as previous, and now pdp is equal to dp. It's not quite space optimized, but whatever. Oh, I'm supposed to put in this ridiculous case. The answers are different. off by a little bit. Why is that? That's not great actually. Actually was expecting it to be the same. K minus 1 again. And oh, I see. Because this should be the base case as well. Oh, I kind of set it up incorrectly. Okay, so now we're still at the same, and then now we just have to optimize out this thing. Yeah, okay, that's not that hard, right? Because then now this is just the sum of all these things, so then now we could do a prefix sum. Yeah. Yeah. Okay, and then now left minus x. So, okay. This left minus thing is a little bit confusing, but should be fine. But anyway, I have to do it in 2 different loops anyway. For the brief. So then now left minus x is greater than 0, so then it goes from, so x actually goes from 1 to left, or 1 to, so x goes from that, or s index plus 1, right? So then now it's equivalent of, I'm gonna get some like off by 1 indexing. Is that true? No, x goes from 1 to the min of that. So then the indexing is going to be, so what is the, okay. This is too hard for me to do normally. Okay, so that means that for min x is x is equal to 1, so we left minus 1. Max x is going to be either left or s index plus 1. In either case, so it's going to be either 0 or left minus s index plus 1. Oh, the plus 1's outside, maybe. So then now effectively we're going from this number is the max of this, max of or from left minus 1, which is left. Okay, so someone like this and then mod it, of course. I'm probably off by 1 or something. Well, this is returning 0. I recognize that number. So we didn't do a prefix sum for the beginning, that's why. No, that's not true. We do it. Right. The indexing is so hard for me in general. I am just really bad at it. Oh no, because it should be inclusive. So the second one should not have this one. Okay, still doesn't change anything, but let's actually print out prefix real quick. Just to make sure that it's doing something. But yeah, it's not doing any. So the prefix is just not right for this one. Plus pre. That doesn't make sense. PDP left from 1 to K. Yeah, so what? Oh, I'm dumb because I put 0 times this and it should be. I suck at programming. Okay, I mean, we have a different wrong answer, but that's good, maybe. I don't know. But at least the prefix sum seems to work, which is good. It doesn't seem to, well, I mean, that's just a function of this thing, I think. So, but at least the prefix sum is actually working, because it's nice to be not an idiot for a second. We have 40 minutes, we should be okay. But the indexing, I'm so bad. Maybe I need a +1 here. Nope. Okay. I know I'm just having off by 1, so let's slow down. Okay, so then we have left is 0, say. I mean, left being 0 doesn't matter. We should never do anything with it anyway, because left of 0 is always 0. So okay, right? Prefix of, so let's say this is 1, then this is 1, which is way wrong. This should be left +1. I think there's a +1 on both sides and I just messed it up. Nope. This is way too big. Is it inclusive or exclusive? I don't know, maybe it's this. Maybe the 0 is, okay, maybe not. No, the 0 should be fine. Okay, let's do this again. We have this loop. This is so hard for me, because I am not a smart man. Okay, so we have this loop that we're trying to optimize. Go from 1. If x is 1, we go to left -1. This part is weird. Oh, it's left -1 +1, so this should be left. I think that's actually right. That's why I was overcounting a bit. Oh, this thing doesn't make sense, but okay. Are we seeing negative numbers? No. We're just seeing really big numbers for some reason. Maybe we are seeing negative numbers, but what should this be? I mean, this is definitely wrong, because it should not be this. Is it the max of this, or is it the min of this? The min doesn't make sense though. Am I just doing a +1 by accident? I am doing +1 by accident. I am just not a smart man, but okay. I mean, you're smart enough to get it done, I think. Let's see if it's actually right. Okay, check your mods, Larry. Alright, let's give it a submit. I'm just a little bit lazy on double checking. I don't know why I submitted the time limited one though. That was not going to be close. But this is good. This is Gucci. A little bit sloppy, a little bit not paying attention. Would have been 75th. Would have been higher if I didn't make. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this contest, this farm, this explanation, everything in between. Stay good, stay healthy, to good mental health. I'll see y'all later. Take care. Bye bye.